Hello, this lesson, a big one, called implicit differentiation, a new technique that you have to learn about differentiation. So previously, you have learned how to differentiate parametrically. So you've learned dy by dx equals dy by dt over dx by dt. We differentiate x, differentiate y, put a derivative of y over x and substitute. Now, today, what you learn is what we call implicit differentiation, means we are differentiate a different variable, but in terms of x. So this is how it goes. So first of all, we have to understand what we mean by an explicit and an implicit equation, because implicit differentiation means differentiating implicitly. Right, so notes, an equation in the form y equals f of x is given explicitly. For example, e.g., so let's say we've got y equals 2x, y equals x squared plus 3, y equals root x plus 3, or if you want to be really horrible, you can say y equals e to the power cos x, I don't know, squared 2, I don't know, x, for example. A really weird equation. It doesn't matter. These are all explicit equations because they're given in the form of y equals f of x. Now, however, not all equations could be rewritten as y as a function easily. For example, e.g., just give you a weird one. So let's say 2 plus x plus 2 cos x plus y equals 3. Now, this equation, you can make y the subject, but it will be very difficult to make y the subject. Or if I actually change this x into y, for example, but just make an example, then you can't really make y the subject in here. So these are called implicit equations. Okay? Implicit equations where you can't really make y the subject, but equation involve both x and y. So these are called implicit equations. Now, before we look into implicit differentiation, we look at explicit differentiation, aka normal differentiation, what you've learned so far since year 12. Or if you did GCSE in further maths in GCSE, you might have done this in 11, sort of since 11. Right, so what do we mean by that? Well, we start off, let's say we've got 2x, y equals 2x cubed plus 6. Okay. Now, we know, okay, I'm going to leave some space in the middle because I'm going to write something in there. Now, we know dy by dx very simply is just 6x squared, right? Because you multiply power divided by 1, power minus 1. But in the middle, so what have we actually done in the middle? We actually have apply d by dx on both sides. Okay, so it's like d by dx of y and d by dx of 2x cubed plus 6. Now, most people will skip this when they teach it because you don't have to know this little intermediate step, what it means. Well, we're applying, so if we differentiate, essentially we're applying d by dx on both sides. So when you say d by dx, what does that mean? Well, d by dx means to differentiate. This d by dx means it's an action symbol or action expression once you differentiate what's coming up. Okay, so d by dx of y means to differentiate y with respect to x. So therefore, differentiate y with respect to x, we get dy by dx. And then this one, to differentiate 2x cubed plus 6, we get 6x squared. Now, we need this actually because when we differentiate implicitly, where things x and y are all muddled up in an equation, you need to know what you're differentiating. Okay. If you think of this, it's actually quite similar to applying ln on both sides in a sense. All right. So let's have a look. Next one then, implicit differentiation. Now, to differentiate implicitly, right? We differentiate each side of the equation. Use onion method. I used to call it onion method because chain rule is like, if you remember what I explained, chain rule is like peeling the onion. The more layers there are, the more tiers you'll come because you have to differentiate more and more. That's chain rule, layer by layer from the outside to the inside. So I used to call it onion method. Anyway, so we differentiate each side of the equation, both sides. When differentiating a function of y with respect to x, we differentiate as if it is x, but we slap a dy by dx. Slap, yes, I'm probably quite angry when I make the notes. Maybe I was hungry back then, hangry. Slap a dy by dx, or we just multiply in a short way. For example, d by dx, if we want to differentiate a function of y, I will do the derivative of y normally, but at the end you can see there's a multiply by d by dx, dy by dx. Okay, so what I mean, that's what it means. Implicit differentiation means if I'm differentiating a variable that is not x, I would go on and differentiate normally that term, but I will have to multiply a dy by dx at the end. Now I'll show you how, okay, in the examples below. There's so many examples I'm going to show you. Right, are there practice questions later? Probably not, but we'll go through it one by one, okay? Example number 1, okay? Differentiate y squared, okay? So differentiate y squared is 2y, so it's 2y. But because y does not match x, therefore I have to multiply by dy by dx. And that's my final answer. So it's 2y dy by dx, okay? If you understand this, you might want to pause and have a go at question 2. Okay, if you're unsure, I can go through with you. Differentiate sine y. Differentiate sine y is sine is cos y. Okay, but because y is not the same as x, it'll be cos y dy by dx. I'll put a bracket in here just to make sure we're not doing cos of y dy by dx. We're cos y times dy by dx. Okay, next one. What about e to the power of y to differentiate? Well, okay, ignore it. If it's not y, okay, tell me what's the derivative of e to the power of x. The derivative. It's just e to the power of x, isn't it? So if I want to differentiate e to the power of y, it's just e to the power of y, but dy by dx. Okay, a slap of dy by dx. Now, next one is a slightly tricky one. xy. This one, we need what we call a product rule. Okay, we need product rule. So I'm going to use a different color just to show you how to work it out. So xy, so it's like uv. Okay, do you remember how to work out the product rule? V du plus u dv. Okay, so product rule is v. So v is y. V times du. Differentiate x is 1 plus u x dv. Differentiate y dy by dx. And that's equal to y plus x dy over dx. Right? So v du plus u dv. Okay, product rule. Next one. Derivative of e to the power of x squared y. Okay, looks complicated. And it is actually not simple. So let me ask you this. Okay, let me ask you this before we go on. Think about this. If I ask you to differentiate, okay, e to the power of x squared, you can pause the video, have a go using chain rule or using a shortcut I've taught you before. How do we differentiate e to the power of x squared? Okay, I'm not sure if you remember, if you want to differentiate powers of e, essentially you just differentiate the power of e itself. So you differentiate x squared is 2x. And then you multiply e itself. Okay, so to differentiate powers of e, you differentiate essentially, so differentiate expression of e, you differentiate the power on its own and multiply it in the front, and then multiply the e term back in. Now we'll do the same in here. Okay, so we'll differentiate the power first. So differentiate power, if I want to differentiate the power, this is a product rule. So this question is about a chain rule. So it's chain plus product rule. Okay, so we need to differentiate the power first. So so that equals to, how do I write it? Okay, so let me use different color. Actually, let me choose a different color. Let me choose a purple. No, what's the purple? Red, orange. So essentially, we're differentiating power times e to the power of x squared y. So what I'm doing in here, again, this is the power derivative of power of e. Okay, and then multiply by e itself. Okay, so like on the side in here, this 2x is the derivative of power, which is the power is x squared. So x squared. So we differentiate x squared with 2x. The same thing in here. You differentiate the power and then multiply by e itself. But to differentiate x squared y, you need product rule. Okay, so you need product rule. So need product rule. I need product rule. So there we go. So to use the product rule, okay, we use v du. So again, that's u v. So v is y times du times x, differentiate x squared, 2x, v du plus u dv, differentiate y, dy over dx. That's all in a bracket times e to the power x squared y. So if I, that is same as 2xy plus x squared dy by dx, bracket e to the power x squared y. And that's the answer. Right? So if you don't understand, try to replay it again, okay, and try to follow it. Right? And if you're happy with this, I would suggest you, a different paper, try to do the e to the power x squared y, differentiate it again. Try it on your own. Okay. Right, next one. Differentiate 10x plus y. So differentiate 10x plus y, that's a chain, this is the chain rule. This is chain rule. Okay. Differentiate from the outside to the inside. Differentiate outside. So what's the derivative of 10? Using the formula booklet, the derivative of 10 is sec squared. So differentiate from the outside to the inside. So differentiate 10 is sec squared. So sec squared x plus y. Because when you differentiate outside, the inside doesn't change. Right? Differentiate 10 is sec squared, okay, x plus y. And then differentiate inside times derivative of inside is differentiate x is 1, differentiate y is dy by dx. Right? So that's a derivative of 10. This is derivative of inside. So differentiate from the outside to the inside, chain rule. And that's why I stress out the importance of knowing chain rule, product rule, and quotient rule, because these rules rule the differentiation. You need them everywhere. Yeah, so even implicit differentiation, we still need to rely on them. Right? So, well, what can we do with these two terms? We can't really do anything. So I'm just going to probably write it a bit neater. If you remember what I said before, we usually put the trigonometry term at the back. So I'm going to put the 1 plus dy by dx in the front times sec squared x plus y, and that's how I would go leave it. Okay, right. So yeah, exam tips. The derivative of xy is extremely common, sort of, which equals to x dy by dx plus y by product rule. So we've done that in an example before. Suggest you remember it. That's how I use it to tell people to remember it. But will I do it now? Probably not. Because if you know your product rule by heart, you can actually generate quite easily. VDU plus UDV. So, but if you don't remember it, you know, feel free. But our brain only got a certain brain cells, which we want to save it for something important, which is, for example, what should we have for dinner tonight? Right, example. Find dy by dx in terms of x and y, where x cubed plus x plus y cubed plus 3y plus x. We want to find dy by dx. So this time, this is an implicit equation, because you can't really separate the y and the x. You can't really make y the subject in here. So what we do is to find dy by dx, we first apply d by dx on both sides as a beginning. Okay, as a whole bracket. Okay, apply d by dx on both sides. This d by dx means to differentiate whatever's coming up next in the bracket. So you want to differentiate, okay, x cubed, which is 2x squared, not 3x squared, sorry. Pardon me, 3x squared. Differentiate x is 1. Or differentiate y cubed. Differentiate normally 3y squared, but y and the x, they're not the same. So you have to slap a dy by dx at the end. Plus 3y, differentiate 3y, imagine it's 3x, you get 3 dy by dx. Now, what about 6? Differentiate 6 on the right side is 0. That is the key step. Okay. Next, I want to make dy by dx. I want to make dy by dx a subject in here. So next step, I want to make dy by dx the subject. Okay. Right, to make dy by dx subject, you have to bring the other term to help dy by dx on the right hand side. So I'll probably bring these two terms to the left hand side. That gives me 3y squared dy by dx plus 3 dy by dx equals negative 3x squared plus 1 and minus 1. And then factorize the dy by dx out. You get 3y squared plus 3 equals negative 3x squared plus minus 1. Divide that bracket over, so dy by dx equals negative 3x squared minus 1 over 3y squared plus 3. And voila, that's done. Right? That's how we do it. Okay. One more. Okay, one more example. Find the value. Find the value means the answer will be a numerical value, numerical answer of dy by dx at the point 1, 1, where e to the power of 2x ln y equals x plus y minus 2. Tell me the first step. Apply dy by dx on both sides. Apply dy by dx on both sides. Both sides, English. Next, left-hand side, to differentiate e to the power of 2x ln y, we need to use product rule because they're multiplied together. Okay, so product rule means that's your u, that's your v. So e to the power of 2x is u, ln y is v. Okay, let's do it. V, the u, differentiate e to the power of 2x to e to the power of 2x plus u, e to the power of 2x, dv. What's the derivative? Derivative of ln? 1 over. So it's 1 over y. And then, but it's a y, it's not an x, so dy by dx equals, right hand side, differentiate x, 1, differentiate y, dy by dx. Okay, differentiate 2, 0. Okay, next. I want to find the value of dy by dx where the point 1, 1. So in here, now there are two things you can do in here, two options you can do. One, you can make dy the subject in here. Dy by dx is subject in here. Okay, option 1, make dy by dx subject. Okay, which you can pause and have a go yourself if you want to. Or 2, I see making dy by dx subject would be quite cumbersome. So I sub in the value straight away. Okay, so I sub 1, 1 into it. This is method 2, which I'm going to use in here. Sub 1, 1. This is my x value, that's my y value. So whenever I see x and y, apart from dy by dx, I'm going to sub in 1 and 1 in there. So ln y becomes ln 1, who e to the power of 2 times 1, plus e to the power of 2x, e to the power of 2 times 1, times 1 over 1 dy by dx equals 1 plus dy by dx. Now, the reason that I actually didn't make dy by dx subject in here is because I sort of knew on top of my head where ln1 is 0. If I sub in here, I could literally get rid of this whole term because this becomes 0. Just let me double check my answer because I can never trust myself with mental maths. What's ln1? ln1 is 0. Indeed, it's 0. Okay, so that's 0. So then I'm just left with this term in here, e squared dy. Oops. I tried to draw the dot to my dy by dx, but I failed. So e squared dy by dx equals 1 plus dy by dx. Now I can make dy by dx a subject here, which is much easier. So if I bring that dy by dx to left hand side, minus dy by dx equals 1. And then I can then factorize the dy by dx out. E squared minus 1 equals 1. Now you can have dy by dx equals 1 over e squared minus 1. And that will be the numerical value. It doesn't look like numerical, but we know e is a number, 2.718. So if you do put in a calculator, it is a numerical value. It's just an exact answer. Okay? Right. If you're happy with this, then before we do the exam practice, let me do a quick recap. To differentiate, okay, to differentiate implicitly, what you want to do is you want to apply d by dx on both sides. Okay? Whenever you are differentiating x, you differentiate normally. Okay? No big deal. But when you differentiate something with y, okay, you go on differentiate, but don't forget to slap a dy by dx. okay, at the end for that term. So for example, if you differentiate y cubed, it becomes 3y squared because differentiate y cubed is 3y squared, but multiplied by dy by dx. Same for the 3y, differentiate 3x is 3, but it's a y, so it's dy by dx. Okay, right, if you're happy with this, again, pause the video, have a go at this exam practice. When you're ready for the, oh, actually, did I give you 2? Oh, there are 2 in here, so one by one. The first one here, it says C4 Gen 2008, question 5. When you're ready for the answer, you can press play. Right, here are the answers for question A, question B. Okay, final answer. If you got it right, well done, move on. Okay, but if you don't, I'm going to explain how do we do that. So a curve is described by this equation, x cubed minus 4y squared equals 12xy. Find the coordinates of the 2 points where the curve, on the curve where x equals minus 8. Part A mentioned nothing about differentiation, nothing. Okay, find the coordinate of 2 points where x equals minus 8. So we just have to do sub x equals minus 8 into the calculator, into the equation, sub x equals minus 8. So minus 8 cubed minus 4y squared equals 12 times negative 8 times y. So negative 8 cubed is negative 512 minus 4y squared equals minus 96y. This becomes a quadratic. I'm going to bring everything around inside. So 0 equals 4y squared minus 96y plus 512. I plug in the calculator and let it solve it for me. I get y equals 8 or minus 16. Sorry, 8 and 16. Oops, 8 and 16. So, right. So, actually, 8 and just 16, not minus 16, 16. So I just have to, therefore, I just have to write them in coordinates. Part A, minus 8, 16, minus 8, 8. Right? Part B, find a gradient. Now, the gradient is like the key to differentiation. When they tell you gradient, you know, you have to use differentiation. Okay? So let's differentiate. Find a gradient of the curve. So differentiate. So if I want to differentiate this implicit differentiation, I need to apply d by dx on both sides to begin with. So d by dx of x cubed minus 4y squared equals derivative d by dx of 12xy. Just make sure I didn't copy it correctly. Minus 4y. Yep. Okay. Left hand side. Let's differentiate. Let's differentiate left hand side. 3x cubed. X cubed is 3x squared. Differentiate 4y squared is 8y. But dy by dx. Right hand side, product rule. Okay, that's your u, that's your v. So 12x is your u, v is your y. Okay, let's do it. V du, v y times du, differentiate 12x, 12, plus u dv, differentiate y, it's just dy by dx. Okay. Next, in here, I'm going to make dy by dx a subject in here. Well, reason being is, sir, why don't you just sub in x and y straight away? Yes, you can. However, I've got 2 points in part A to find a gradient, so I need to find 2 gradients. So I might as well just make dy by dx a subject first, so I get 1 gradient function, so I can apply 2 points in there, rather than, you know, substitute and then rearrange for both equations. Okay, so I'm going to make dy by dx subject in here. However, if you want to sub it in now, you know, be my guest and do it now, whichever way. I'm actually going to bring the minus 8y dy by dx to the right hand side and bring this to the left hand side. So give me 3x squared minus 12y equal 12x dy by dx plus 8y dy by dx. I can then factorize the dy by dx out, and then so 3x squared minus 12y equals dy by dx, 12x plus 8y. I divide it across and just swap the left and right. So dy by dx equals 3x squared minus 12y over 12x plus 8y. You don't have to simplify anything in terms of algebra. The reason being is I'm not sure if there is anything you can do in here. However, because all we care is substitution. So I'm going to sub in the points minus 8, 16 and minus 8, 8. So minus 8, 16. So when I sub in, minus 8, 16 into that. So dy by dx, if you put in a calculator, you should get 0. And if you substitute minus 8 in the calculator, your gradient you get in here is -3. And this is how you get the answers. Okay. Right, so the question asks for gradient, differentiate. But you realize there's x and y, so you have to differentiate implicitly. Next one. Okay. Pause the video. Okay. Have a go at the question. When you're ready for the answer, you can press play. Here are the answers for the answer, part A, part B. 10-mark question, quite a lot to do. Okay, so here are the answers. If you got it right, well done. Okay, the lesson is over for you. Time to do the homework. But if you don't, let's go through why. Question A, find dy by dx. Well, you see this question, quite a chunky one. So implicit differentiation. So first, I'm going to apply dy by dx on both sides. Okay. Next, I'm going to differentiate one by one. Now, this step, the first step, doesn't give you any marks, but it's just a good habit to show you know what you're doing in here. So I'm going to differentiate one by one. Differentiate x squared, 2x. Differentiate y squared, 2y. But y is not the same as x. Okay, dy by dx. Okay. Differentiate 10x, 10. Differentiate 2y is 2. But y is not x, like Pepsi is not Coke, so dy by dx. 4xy, product rule. A product rule. That's your u, that's your v. So because there's a minus in the front, I'll put it just a minus and then put a bracket in there. Okay, so I can just deal with the minus later. Product rule. v du plus u dv. Okay, v is y, du. Differentiate 4x, 4. Last u for x, the dv, dy by dx. Differentiate 10, 0. Okay. Now, the good thing about video is, okay, if you got wrong, okay, you don't know how to start, I've started you off, you can pause anytime and continue with where I haven't done it yet. So if you got stuck in the first step, now I've done the first step for you, then go on. Okay, carry on. The question wants me to find dy by dx, so I'm going to make dy by dx subject in here. So I'm going to factorize dy by dx right, in here altogether. So dy by dx, well, actually what I'll do is there are terms that are not dy by dx, so I'm going to bring this term to the right hand side. There's 2x, there's 10, there's minus y over minus 4y, should go on the right hand side. The rest of them, I can factorize dy by dx. So this 2y dy by dx, 2y plus 2. This one is a minus 4x, so minus 4x. Equal, bring everything right side, minus 2x, minus 10, plus 4y. Okay, and then I'm going to divide it over, so dy by dx equal minus 2x, minus 10y, minus 10. Where's the y come from? Plus 4y. Divided by 2y plus 2 minus 4x. I see every single term are even, so I divide everything by 2, top and bottom. So minus x minus 5 plus 2y over y plus 1 minus 2x. Let me check my answer. Minus x minus 5. Yep, plus 2y over, yes, so my answer is the second one in here. Okay, it depends where you put the dy by dx, but both are equally fine. Part B, okay, again, if you haven't done it yet, then you can go on and do part B because you couldn't do part A, now you can do part B. Okay, pause, play anytime you want and pause anytime you want, okay? I can't stop you there and I'm not coming to hold your hand and say play, pause, play, pause. Part B, find the values for y which dy by dx equals 0. We're simple, we're told dy by dx equals 0, so let's do that. So I'm going to dy by dx equals 0. So, the first step is simple because we're going to do minus 5 minus x minus 5 plus 2y over y plus 1 minus 2x equals 0. And multiply the whole thing to right hand side, that's just gone. Okay? Minus x minus 5 plus 2y equals 0. Okay? Just gone. Right? Just gone. Like the burger McDonald's, just gone. So multiply over, just gone. Now next, what can you do then? Right? You want dy by dx equals 0. So you've got an equation here. So the question is, what do you do next? I want to find the values of y for which dy by dx equals 0. So I've got one equation. To find value of y, I sub in to the original. Right? So I'm going to make x subject in here. So if I bring x around inside, it becomes minus 5 plus 2y equals x. So x equals minus 5 plus 2y. I'm going to substitute sub into the original, which is, can't remember now, x squared plus y squared, x squared plus y squared plus 10x plus 2y minus 4xy equals 10. Yep, it's going to be quite messy, but that's why it's 5 marks. So x squared is going to be minus 5 plus 2y squared plus y squared. Just color code it for you. This x, I'm replacing it. This x, I'm replacing it. This x, I'm replacing it. So plus y squared plus 10x, x minus 5 plus 2y plus 2y minus 4x times y equals 10. Next, got no choice but to expand it and try to simplify the algebra. So expand the bracket. Minus 5 squared is 25. 3 times 5 times 2 is negative 20, is negative 20y plus 4y squared plus y squared. 10 times negative 5 is negative 50 plus 20y plus 2y. Oh, this one. Minus 4 times minus 5 plus 2y. This one, minus 4, is like minus 4 times 5 times 6, for example. You can rearrange it, make it minus 4 times 6 times 5. So it's like saying minus 4 times y, so minus 4y times the bracket. Okay, so minus 4y times the bracket is plus 20y. Minus 4y times positive 2y, negative 8y squared equals 10. Now, hopefully, you can see this becomes a quadratic. Okay, quite a long quadratic, but you can simplify the terms and make it into really, really neat quadratic in here. But your algebra, you have to be extremely careful with your algebra in here. Right? So what I'll do is I'll usually use a pencil to cross out the terms that I have taken care of. So I start with the y squared because I realize it's a quadratic, so I start from y squared term. 4y plus 4y squared plus y squared is 5y squared minus 8y squared. That's negative 3y squared. Right? Next, start with the y term. Negative 20y plus 20y is gone, 0. 0 plus 20y, oh, plus 2y plus 22y. Okay. Next one, last, the constant term. 25 minus 50, negative 25, or you can use a calculator, of course. Negative 25. If I bring this 10 over, negative 25 minus 10 is negative 35, which equals 0. Right? Yep, I did right. Then you can plug in the calculator and pray, hope for the best. It give you the answer, and you should, and you will get y equals to 7 over 3 or 5, which is the final answer that you need. Quite a long question, but here you go. Right? Thank you for listening, and that's the end of implicit differentiation.